Good morning, everybody. I think we are ready to start. I'm Reza Navai, Assistant Division Chief for Transportation Planning with Caltrans. My apologies for the late start due to technical difficulties. On behalf of Caltrans and CTC, I would like to welcome all of you who are joining us today in person and via webcast to the first of two training sessions on the use of CalBC for SB1 projects and, for that matter, any other project that you may find CalBC useful. The second session is on Tuesday, January 16th in Los Angeles at Caltrans District 7 facilities. A majority of today's training will focus on benefit cost analysis and CalBC tools. CalBC is a mature, nationally recognized model and been in use for quite some time. The model is used in a wide range of projects, including Prop 1B funds a few years back. Of course, like any models, CalBC has limitations, as well, and one of the objectives of this workshop is to discuss what types of project CalBC modules could perform and what projects are outside of the capability of the module at this time. As you know, SB1 provides at least four new funding grant programs: local streets and roads program, local partnership program, trade corridor enhancement program, solutions for congested corridors program. All of these programs, except the local streets and roads program, require CalBC analysis. We have updated CalBC modules for this round of SB1 applications given the tight time frame we had, and we will make further refinements as needed for the future cycles. Again, thank you for attending this workshop. Hope you will find this session helpful in preparing analytic requirements of your application. Thank you and best of luck to you on your SB1 applications.
All right, good afternoon, or good morning, everyone. I'm Ryan Ong, I'm a staff economist with Caltrans' economic branch. And just to provide you some insight on what we're going to talk about today, first I'm going to provide an overview of what a benefit cost analysis is. Rosa Aguirre, my supervisor, will be covering CalBC framework, and then we'll jump into the heart of what you guys are probably here for, which is how to run the tool and what the tool can do. So there's several components of what we call a suite of CalBC tools. One's kind of framed as the regular tool, which we'll cover around 10 o'clock. And then there's CalBC active transportation. There's CalBC corridor. It's CalBC intermodal freight. And then finally there's the SB1 emission calculator. So all these tools are critical for SB1 programs, and should be, depending on the program that you apply for, you'll want to use each tool accordingly. So I'll just jump right into the overview of what a benefit cost analysis is. So basically a benefit cost analysis is an objective, systematic social welfare analysis of benefits and costs over time. It can evaluate a project, policy, or decision or choice to ensure that the decision or choice is efficient and effective given limited resources. In this case, SB1 has limited resources to fund, and so we want to make sure we're funding the best project out there for the public and stakeholders. So a benefit cost analysis methodology sort of serves as a framework to objectively analyze your project, and a benefit cost analysis is not only applicable to transportation, but it can be applied across other institutions or other industries. For example, the first notable benefit cost analysis was done in the mid-1930s, and it was required by the federal government to analyze flood control projects. And then the federal government in the 1950s actually went through a process of standardizing benefit cost analysis methodologies. So the benefit cost analysis methodology has been around for a while. Now, benefit cost analysis considers quantifiable benefits and cost variables that can be monetized. That's the important factor, is it's quantifiable and it can be monetized. The variations or the valuation of variables are typically supported through research, academia, contingent valuations such as surveys, or even open markets. Not all variables are monetized, and I want to point that out. Some benefits you can't simply monetize or quantify. An example would be civic pride. So you may want to use a different methodology for intangible benefits to capture that. So civic pride may be from the construction of a park or a sports venue. You know, how much value does somebody get out of that? And so that's difficult to quantify or measure. So I just want to reiterate that that's not captured in a benefit cost analysis. So another important thing about benefit cost analysis is that it can evaluate the benefits and costs that can be monetized over time by quantifying it to today's dollars, otherwise known as the present value. And that's key because when you're comparing projects, you want to make sure that you're matching apples to apples. So that's why we bring it to the present value. So when you bring it to the present value, you can compare them and prioritize and rank them and allocate resources accordingly to the best and most efficient project. So this diagram that you see up here, the green represents what we call traditional transportation benefits, your travel time savings, vehicle operation costs, safety, and emissions. And then the red box represents basically the costs that are associated through the life of your project, such as your capital costs, operation, and maintenance. From there, it's a simple measure of dividing your benefits over your costs to get a benefit cost ratio, or a measure of effectiveness. So the rule of thumb is anything that's greater than 1 ratio is a good project because your benefits outweigh what your costs are. And then this further defines what your traditional transportation user benefits are. You have your travel time savings, which is basically the difference between your status quo or your no-build project with your current situation and comparing it against what the project can save people from traveling. And so that's kind of the net difference of the difference between your no-build and your build scenarios. The same thing applies to vehicle operation costs. That's your fuel consumption, brake wear, tire wear, and other vehicle-related maintenance or depreciation. Accidents is basically a function of, sorry, that's on the next slide. I'll get to that. So basically accidents is just, the safety benefits that you may receive from a project. Emission costs, there's 6 pollutants that CalBC can measure, and I'm sure we'll get into that more later. Then there's your journey quality. So the green text represents kind of new emerging benefits that can be quantified with recent academia support. So journey quality is really geared toward the active transportation, and it's measuring the safety improvements and benefits that you receive from biking and walking. Health is a reduction in absenteeism. If you walk and bike more, you're less likely to call in sick. You may be healthier, and also against premature deaths. The shipper cost savings is a reduction in shipping costs from freight movement, which can lead to savings for businesses and consumers. And then travel time reliability is basically kind of a more recent concept that looks at the dependability of the network that you use. You know, how reliable is it? Or do you have to anticipate accidents, or is it really dependable where you can get to your work home from work in 20 minutes? Yeah, and then as mentioned before, benefit cost analysis doesn't cover all potential benefits. And I just want to make the distinction, too, that benefit cost analysis is really looking at the user benefits of the system and as well as some societal benefits such as emissions. It's not, sometimes people get confused with economic impact analyses, which is focusing on jobs and the circulation and flow of money and how it circulates through the local economy or whatever economy you're trying to analyze. So there's a distinct distinction between the two of those. And then this slide right here gets into the kind of the crux of what the indicators or factors would be when you're quantifying. So for example, travel time savings is a function of volume and speed. Vehicle operation costs is a function of volume, speed, fuel consumption, wear and tear on your vehicle. Accident is a function of volume, accident, and facility type. Emission is a function of volume, speed, and emission rate. And journey quality is basically your trips, distance, and speed. And as mentioned, journey quality, health, and are more geared toward the active transportation tool. So health gets at the function of trips, sick days, and wages. And reduced mortality risk gets at the function of trips, distance, and mortality rates. And for the logistics and the shipping costs, basically the intermodal facility tool, it looks at volume, capacity, and shipping costs. And then if you want to get technical, this is the formula that's laid out in front of you guys. But it's important to note that these four categories are all measures that can determine if your project's worth funding. But the most common one is the benefit cost ratio. Another one to be kind of look at, it would be, already mentioned the net present value, but also look at the internal rate of return and your payback period. And the typical steps to conduct a benefit cost analysis is basically you want to look at over a length of time or a horizon. With CalBC, it looks at a 20-year horizon. And you want to compare, your build versus your no-build scenarios. And then step two would be to calculate the difference in impact to estimate benefits and to convert it into dollar values. Again, that's taking what you're trying to measure, quantifying it, and then converting into dollar monetary terms. And then step three would be to discount it, and then the benefits and project costs, and bring it to the present value. And then step four, again, just to reiterate, is the look at the measures of your project to see if it's worth funding. It would be your benefit cost ratio, your net present value, your internal rate of return, and then your payback period. And the good thing about this is CalBC can do this all for you. So with that, I will turn it over to Rose, and she'll discuss actually the CalBC framework. Thank you.
Good morning, everyone. I'm Rose Sagser, and excuse me, I head the Transportation Economic Branch here at Caltrans. So, CalBC, the California Benefit Cost, excuse me, the California Benefit Cost model was developed by the department by the mid-1990s in response to a recommendation by the Commission on Transportation Investments and the CTC STIP guidelines. CABC is based on methodology of an older highway economic evaluation model, a model on a mainframe. The development of prototype in-house BC tool was contracted out when formally recommended by the Commission. Over the last 2 decades, CalBC has been upgraded and expanded to add capability to assess a wide variety of projects, highway and public transit projects, corridor analysis, pedestrian and bike projects, and for these SB1 intermodal freight types of projects. CalBC was designed as an Excel worksheet and not a black box. One can trace the formulas used to quantify the benefits. It contained a number of default values, such as highway operation parameters like average vehicle occupancy and lane capacity. Another example is unit user cost, value of time for both autos and trucks, and average cost of accidents, as well as vehicle fuel consumption and operation cost, emission rates by vehicle types and various speeds, and economic parameters like discount rate. So CalBC framework, again, has been expanded over the years from a single model to a suite of tools. The CalBC corridor was developed recognizing the need to post-process planning model data when applicants have access to travel demand and microsimulation data. Added tools, we added CABC's other suite of tools to cover other modes like the active transportation to accommodate pedestrian and bike projects. All these CABC tools in the CABC framework uses the same assumptions and parameters. So this is a picture of the CABC framework. Again, the CABC regular is a sketch planning tool for project assessment. This tool is used mostly when potential project impacts are not fully known because minimal data is needed to run the analysis. Types of projects that could be analyzed with this model is you can do highway capacity expansion, like lane additions, HOV lanes, as well as transit capacity expansion, and operational types of improvements and TMS like ramp metering and aux lane, off-ramp and on-ramp. So the next one here on the picture is CalBC Active Transportation, basically for walk and bike projects. This CalBC Active Transportation reflects recommended updates to a first-generation benefit cost analysis tool that we developed, that Caltrans developed in 2014 in conjunction with the Active Transportation Program selection process. Refinements include improved specification of data entry, requirements, expanded set of benefit categories, updated benefit estimation, and integration of additional data from different sources like the 2010 California Household Travel Survey, Bureau of U.S. Census Bureau, and labor statistics. We also have CalBC Park and Ride. However, CalBC Park and Ride is another tool, and it's based upon a tool developed in 2013 for Caltrans District 12, where it estimates the benefit of new park and ride lots, park and ride lot expansions, and lease lots. However, for this round for SB1 programs, CalBC Park and Ride wasn't updated consistent with the other CalBC suites of tools. So this workshop will not really cover park and ride. we anticipate that there will be limited number of park and ride projects. Depending on the interest from the group, from stakeholders, we can try to update the tool in time for people to use this for SB1. But for now, among all these 5 modules, we have the COB-PC Park and Ride, but we just need to make it update some parameters to be consistent with the other suite of tools. Okay. And lastly, the COB-PC Intermodal Freight. It's a brand new tool. It's the type of projects that it will analyze. Type of projects include modal diversion and freight network improvements, transload operations, and terminal efficiency improvements. So for COB-PC models, it uses consistent methods. All the parameters are linked together. So when the COB-PC regular COB-PC house all the parameters, and so if it needs to be updated, all the other models will be updated as well for consistent methodology. It uses similar user interface, and again, it relies on the same parameters. It produces comparable results and have built-in instruction pages, and it supports across multi-modes. The COB-PC regular can run one project at a time, or it can run different elements of a project. And with this different suite of tools, COB-PC framework also support analysis across multi-modes. So the structure across models, there's 10 tabs within the tool, but the 4 ones that most people ready to use is the project information sheet. That is it collects descriptive information about the projects. It is the main data entry sheet where one enters project description, highway design, traffic data, highway accident data, rail and transit data, and project costs to run the analysis. The model inputs model inputs tab allow users to check the data by model from what was entered on the project information sheet and override calculated values if they have information more specific to their project. And then the results page, I will show you the shot screen later on, but the results page, it presents the final investment measures as well as annualized and 20-year benefits of a project. And then the last tab is the parameters page, the last sheet that contains all the economic values and rate tables in the models. Here are some of the few standard parameters used across the models. So you have general economic values, highway operation measures, like your maximum benefit cost, vehicle VC ratio, percent ADT in peak period, as well as travel time values, highway accident costs, and user operating costs. Highway emission rates as well for 6 CO, CO2, nitrogen oxide, PM10, SOX, and VOX. We've included PM 2.5, but we've only reported in tonnage and not associated any. It did not give a monetary value. As I said about earlier, the result page are consistent across models, and so you have your life cycle cost, life cycle benefits, net present value, benefit cost ratio, rate of return, and payback period through, I believe, through all the models. And then the itemized benefits, the 4 major user benefits quantified in the model, travel time savings, vehicle operating cost savings, accident cost savings, and emission cost savings. So this is the CalBC regular, and this is the CalBC corridor. As you can see, they're pretty consistent. This is the CalBC active transportation summary result sheet, and as you notice, due to the nature of the project, the benefits, we've included journey quality, additional delay savings, additional safety benefits, and health benefits. Whereas the other models, you have the vehicle operating cost savings, travel time savings, emissions. So it's just additional because it's a different mode. So, and for the brand new intermodal freight, this is the results page. Again, you have accident cost savings as one of the benefits and emission cost savings benefits, but the additional here is the cheaper cost savings and broken down into those type of improvements, modal diversion and freight network improvements, as well as transload and efficiency improvements. So that lays out the foundation, the framework, CalBC framework. So Chris Willigas from HDR will take it from here.
Can I just do some else? Hi, sorry, I forgot to mention that the slides and the recording of this presentation will be posted on the Caltrans's Economics branch's website. In addition, if you have any questions, please email eab.dot.ca.gov. Thanks. And Chris will be coming up to speak.
So before I get into talking about the CalBC regular tool, I just wanted to see if there were any questions up until this point. And I don't know if we've gotten any online either. Okay, so why don't we go ahead and address a couple online, and I see there are a few in the room too.
Do you want to do online first? Or?
Sure, why don't you?
So the first one is from Caltrans staff. Does the tool incorporate bicycle and transit modes as well as cars and trucks? And this pertains to the CalBC corridor.
Okay. Yeah, so the way that the suite of tools have been developed so far, we have separate tools for different modes. And so if you look at the benefits of active transportation projects, there is a specific tool for active transportation, and there is a separate tool or set of tools for the highway and transit modes. And we can put the benefits together. But one of the things I think this question is getting at is something that we have contemplated over the years about updating CalBC corridor to include other modes. Just getting into the history of that model, CalBC corridor was developed about 10, 12 years ago when the state of California was conducting corridor system management plans. And so, that was an effort looking at corridors across the state, trying to figure out how to optimize traffic, primarily on the highway and parallel routes. So at the time, there was a lot of microsimulation modeling effort, and this tool was developed really to post-process the microsimulation modeling data, hence the name CalBC Corridor for those corridor system management plans. But what we found was you could also post-process travel demand model data. So for MPOs, and there have been a number of MPOs in the state that have used CalBC Corridor for their RTPs, we found that you can run the travel demand model data, and because of the flexible design, you can post-process it. But it was focused primarily on the highways. And so in the future, one of the updates we've talked about is adding in those transit modes as well, so you can pull in the transit data from a travel demand model. There are ways to work around it now, and there are a few MPOs that have done that where you can trick the model to pull in the transit data as is. And so if anybody is needing to do that, just contact Caltrans staff and they can show you how to incorporate those other modes in the tools. So.
Good morning. My name is Eric Chen. This is Mahendra. We're from District 10. Sorry late, so we didn't catch the beginning. I was wondering, is this going to be a workshop or is it just going to be an overview? We'd like to ask questions on the CalBC itself, and we actually learn from Rose about a month ago, and we're trying to do some in-house for District 10. And we've been running into a lot of problems, and we're not getting the results that we want.
Mm-hmm.
And we have a lot of questions on some of these cells, what to input. And I was wondering if this class is going to help us answer these questions.
So
we emailed those questions, by the way, 2 days ago to Rose.
okay.
So if you don't have those questions, we brought one printout. Maybe we can pass it on and you can look at that and
Okay.
try to answer those questions. That would be really fruitful.
Great. Well, so what we're planning on doing today is, up until this point, we've been just doing an overview of benefit cost analysis and the CalBC framework overall. We're going to go into each tool specifically, and what we've tried to do is set aside a little bit of time to answer questions about each tool as we go through the tools. So I hope you ask some of those questions as we go over the tools. We want to try to keep to our time frame. So what we also have is at the end of the day, we have about 45, 50 minutes set aside just to do follow-up questions. So if we cut people off on questions about specific tools, we'll kind of park them on the side, but we'll bring it back at the end. We just want to make sure we have time to get through everything. And the other thing is, if there are specific questions we don't get into today, or there are other questions that arise, please contact the Transportation Economics branch, and they will route the questions. They'll answer the questions because the department is really committed to providing the support you need to do the benefit cost analysis for the SB1 applications. So.
Hi, my name is Francis Lowe, and I'm representing CCTA. I'm a consultant to them. We recently finished using the KLPC model as part of the SB1 application, and of course, once you run models, sometimes a lot of the results aren't what you're expecting. And one of the difficulties that we have is as we go into the Excel spreadsheet to try and figure out, what are the factors that go in that affects the outcome. Mm-hmm. A lot of the cells are not your typical A5, Z13 cell number that we're used to in Excel. A lot of the cells have got names. And so for us to really try and decipher what those things are, we can't, we don't know where those cells are. And so if it's possible, if there could be an Excel that's exactly the same thing, but not using a special name for the cells and just use the cell address like you would in a typical Excel spreadsheet, that would be really, really helpful.
Okay. Yeah, when the model was designed, and the first model was designed about 25 years ago, and we did use range names, so basically variable declarations in the Excel files, mainly because the calls would start to get very complicated because you'd see links across different sheets, and so most of those range names that they're referencing are in the parameters page. So if you go to the back of the model, there's a sheet that has the set of parameters, the economic values and engineering judgment values that are included in all the models. And by the way, it's the same parameters page in every one of these models. So if you click on those, those range names should be there. And we tried to make them as intuitive as possible. But I hear you with the question, and we'll think about whether it makes sense to strip those out and put in formulas. And in the meantime, if you have any questions with specific applications, just let us know. We can help you with that. So we have a question in the back too.
Yeah, hi. My name is Jason Moody. I'm with a consulting firm that helps out MPOs and others apply these tools. A couple of quick questions. You kept mentioning the term post-processing. Can you just quickly describe what you mean by that term?
Sure. So what post-processing means is to take the data from a travel demand model, take the output data, or take the output data from a microsimulation model, and then use the CalBC tool just to calculate the economic benefits. Right. So you're processing the data you pulled out of the model.
Gotcha.
And we'll get into the CalBC corridor model a little bit later, but we tried to design a very flexible framework. So it's not specific to any particular MPO's model, and it should be outputs that are relatively easy to get. You can do it. You can pull the data out by speed bit, which would be what a lot of people do for emissions or quality conformity. You can also pull data out by segments. We've also had people use the data where it was a little simple project. They used highway capacity manual methods or HCS, software, did their calculations, and then used the CalBC corridor spreadsheet as like their workbook. They typed the data in and gave them the benefit.
Okay.
So it's intended to be very flexible.
Earlier on, you mentioned travel time reliability. Is that something that you guys are going to talk about later about how you would estimate the benefits or monetize those?
Sure.
Yeah,
I can go through this. We didn't put specific slides together, but I can make sure that we talk about it as we go through, and I'll use the CalBC tool as an example for that.
Last quick question. The one on AT is primarily about quality of travel time and I guess mortality, health effects. Mm-hmm. Is there a quality of travel time module or consideration to other modes?
No, and so there has been some confusion about what that journey quality value means, and so I'll talk about it a little bit right now, and I know we'll go through a little more when we get to the ATP model. But the journey quality measure was supposed to capture the effect of if someone is riding their bike along a roadway, and then they move to a separated bike facility, there is a certain benefit they derive, just a feeling of comfort, just not being next to all the traffic on the roadway. You can't point to an accident rate change. I mean, it's not that there may be accident rate changes, but people will actually divert out of their way to go to a dedicated bike lane to get off the road. I mean, they don't want to do that. And so there have been a number of economic studies that put a value on what are people willing to do to divert to different kinds of facilities, which measures what the value of that facility is to them. But if you look at why they did that diversion, it could be because it's faster, because maybe the facility has bypasses lights or difficult crossings, or it could be because it's safer, or it could be because it's this presumed being safer. And so what the journey quality benefit does is it captures all of those benefits together. So it's really analogous to both the travel time savings and the safety benefits you would see on the highway side. And to be conservative in our estimate of benefits, we don't estimate the travel time savings separately or the safety savings separately for those active transportation modes because we just don't want to double count.
So it wouldn't be, for example, someone is taking a ferry or some other type of mode where they feel like it's more comfortable than sitting through a traffic jam. There's no benefit for that type of travel quality?
Well, for a ferry project, that's another story. No, there is a benefit to that, but the journey quality benefit we have doesn't capture that. There is a journey quality benefit associated with that, but frankly, we just didn't look at that, in the research. But you're right. There is that, productive time component. I mean, I can tell you, I take Golden Gate Transit every day, and I like taking the bus because I can work on the bus as I go into work, and it's so much easier than driving. But I mean, it's a personal preference, but I get a productivity benefit out of that. But that's not included right now.
So did you develop the DC tool from the beginning, or are you getting more in the last version?
So I've been involved with developing the CalBC tool since the 90s, for more than 20 years.
And you are with HDR?
I'm with HDR, that's right. So the evolution of the tools is that in the mid-90s, it was actually a recommendation that came out in the late 80s from McKinsey that said the department should really start looking more at performance-based planning, and one of the recommendations was to include benefit cost analysis. And so there was a tool that was developed in-house called CalBC, and then there was a separate tool called RailBC, which looked at the inter-regional rail projects that the state rail program used. And those two tools were then merged into CalBC. And so, the new CalBC, new in 1998, CalBC merged those two tools together. And I was involved, from that point on with the development of the CalBC tools.
I'm sorry to interrupt, but for people here in the audience, if you guys can use the mic so people can hear on the web recording. Appreciate it. Thank you.
No question.
No more questions? Do we have any other questions online? So it looks like we have answered all the questions so far, but oh, there is one more coming through?
Is this capable of calculating for new freeway alignment and provide vertical clearance projects?
So for new freeway alignment projects, there are a couple of ways you could analyze those projects. If you wanted to use a sketch planning method, so you don't have a lot of planning data, you haven't run a travel demand model to show what the benefits are. I mean, one way you could do that is to look at it as a bypass past your existing routes. So with a new freeway facility, there probably is a route someone was taking before. And I mean, I do know there's some cases in the state where there wasn't. But if there was another route you could take, whether it's a freeway facility or a conventional highway, you would use that as your existing route and then compare the new facility to that, and you can see what kinds of diversion occurs. And so the CalBC model can handle that. Ideally, you'd probably, particularly if it's in an urban or a metropolitan area, you'd want to run a travel demand model and see what kinds of route reassignment is occurring within the region. A travel demand model does, admittedly, a much better job than a sketch planning tool would do. And so, I'd recommend you do that. If this is a new route in a new location, there are no alternative routes, and you don't have a travel demand model, that's where we probably need to talk, because then I think it would be harder to analyze that in the tools. Oh, and sorry, the vertical clearance was another part of that question. No, we currently don't have the ability to look at vertical clearance projects. I think the way you would have to handle that is typically a vertical clearance project would affect size of vehicles, so certain vehicles would have to divert. So it would be a calculation of, what's the diversion occurring now with not adequate vertical clearance versus what would happen if you had adequate vertical clearance for those vehicles. And you can either do that off model or in CalBC corridor. Okay, so I'm going to move on and talk about the CalBC tool, which was sort of the granddaddy of all of these different tools that we're talking about. The tool was really set up to be a simple sketch planning tool. And just to put it in context of why this tool was developed, Caltrans would get a request to analyze about 100, 150 projects in a 2-week time period as part of the interregional program within the STIP. And they needed a quick way to do an assessment of, is this a good project, is it not? What are the benefits? How do the benefits compare to the costs of the project? And so this tool was set up as a way to do very fast benefit cost analyses. And it was also recognized that at that time, there wouldn't necessarily be all the planning data that you might have for a more fully developed project. And so it's set up as this simple sketch planning tool with rules of thumb built in. And one of the things that was innovative about the model is you have this input page on step 1 where you enter in really simple data. I mean, if it's a highway project, things like ADT, number of lanes, what the free flow speed is, and some other information that lets you define what the peak periods look like. And from that, it does a series of assumptions and calculates very detailed data. So it calculates speeds and volumes by different time periods in the base conditions and the future conditions, and it presents that to you on a second page. And then it allows you the opportunity to override those values if your real-world data says something different. And so the idea was you could start with really simple data, come up with a benefit cost calculation, but you can refine it. So, on that second page, you can change the numbers. And then on the third page, it shows the results. It was set up from the start as a spreadsheet. It's always been a spreadsheet. We've tried to make it as open, not black boxy as we can, although, there was a question earlier about maybe it is black boxy with, the range values. We've tried to make it as open as possible. So there are really no macros in the model. I mean, everything is calculated in the spreadsheet, so you should be able to follow all the different calculations. There is one single macro in CalBC, and I'll talk about that in a second, but really all it does is move data around to make it convenient for you to do an analysis. The CalBC model and all of the subsequent flavors of CalBC use the same set of parameters. And so the default lookups, the economic values, all of the economic assumptions like discount rate and the value of time and all of those different things are all back in a parameters page. And it is the exact same parameters page in every single version of CalBC. And that was purposely done because we really want the benefit cost results from whatever tool you use to be comparable. So, we use the same rates in each tool. The CalBC model, as that sketch planning model, is set up to do just highway and transit projects. And, we recognize the need to expand other modes, and that's why we've gone to active transportation and the intermodal freight tools, which we'll talk about later. But when the CalBC tool was set up, it was to do that kind of quick sketch planning for highway modes and also for transit modes. So, when I mentioned that evolution earlier of the CalBC model, we pulled in a model that the rail program was using for assessing passenger rail projects. I mean, these are the state-subsidized long-distance Amtrak routes. But at the same time we were doing that, we went ahead and updated the model to handle light rail projects, bus projects, and so, a number of different transit modes. Ferry we have not incorporated, and we really don't have any tools right now to accommodate ferry projects. But we do have the transit projects built into CalBC, and as we've done subsequent updates over the years, and we've incorporated other things, we've also updated not just the highway side, but all the transit parts as well. And one example of that is we added in ITS type improvements over the years, and so we added in signal preemption for buses, for example. And so the model is intended to be multimodal. To date, it's been used a lot more for highway projects than it has been for the transit modes, although about 10 or 15 years ago, there was an Assembly bill requirement to do a statewide rail analysis, and that included not just the state-supported Amtrak routes, but also all the various transit agency rail routes as well, the heavy rails like BART or the Red Line, and also the light rail routes. And so the model was used for that analysis. The CalBC model calculates four main benefits. They're the benefits that Ryan had showed at the top of his screen that was color-coded with different benefits. It's travel time benefits, vehicle operating cost benefits, accidents, and emissions. We've expanded beyond those four benefits for some other modes, but it's really modally specific benefits, and we're not trying to add extra benefits to a particular mode. It's just sort of the analogous benefits. I think I covered the other parts of this slide. So here's the laundry list of projects that are covered in CalBC. We organized them by different categories. I think different people can quibble about whether we put them in the right categories. Don't get too hung up about where we put them. It was just to try to organize the list. But we have a number of different highway capacity expansion projects, and we list about 8 or 10 different types of projects on the screen. I think when the model was first developed, there were like 3 or 4. So this has kind of expanded over time, and as we've been exploring with different ways of managing and expanding the highway system, we've added things like hot lanes or managed lanes. And when that was first developed, it was called a hot lane module. Now it's managed lanes, and maybe we should call it express lanes because the terminology has changed. But it will handle any situation where you have a dedicated right-of-way and you have some sort of pricing on that facility. HOV lanes, general purpose lane additions we can do. There is a algorithm there to calculate truck climbing or passing lanes, where you may have a rural conventional highway, you have a passing lane portion, and the benefits there are calculated based on some research that shows what are the kinds of delays people experience when they have a moving bottleneck behind another vehicle, and how much time would they save getting around it. That's generally how they calculate those kinds of benefits. We recently added truck-only lanes, as there are a couple of different jurisdictions around the state that are thinking about truck-only lanes. So we do have the capability to do that. That was just recently added. We can handle intersections and bypass projects as well. Bypass projects were big 10, 15 years ago. I don't think we've seen as many over the last few years. One thing I'd note, though, when we talk about intersection projects, we really do mean two conventional highways coming to an intersection, not signalized intersections, because we don't have anything to handle the signalization. So if you're looking at a surface route project, this is where we have some limitations right now in CalBC. If you have data that's an output from, say, Synchro, that's looking at the signal timing and you know what's going on the corridor, you can use CalBC Corridor to estimate those benefits. And if you have a complex interchange project on the freeway, years ago this intersection capability used to be called intersections and interchanges. Frankly, an interchange is really complicated to analyze because you have 12 different movements that can be affected. And so the best way to analyze that really would be to run a microsimulation model to show what are the benefits of different interchange improvements. And I think Dimitri's going to show an example of that a little bit later, where you take microsimulation model data from the interchange and then you put that into CalBC Corridor and can calculate the benefits.
So, can I ask a question?
Sure.
So if we have interchange that is a connector, freeway to freeway,
Yes.
but it also, if there was just an isolated connector, you would just select under operational improvement a subcategory of the first one that has HOV connector. But usually that's not the case. You always have a basket, as you mentioned, and we have like aux lanes, we have off and on-ramp widening, all together. What do you select?
So if you have a really complicated project, then you probably would want to have microsimulation model data to understand the complexities of the traffic operations, because all of the benefits in the regular CalBC tool are simple rules of thumb. So the benefits of an aux lane is based on simulation research of what the weaving occurs with an aux lane. With a rent metering project, for example, it is based on some modeling that was done years ago for the transportation management, TMS, Transportation Management Systems Master Plan, to look at what the benefits of different ITS improvements would be. And so if you don't have detailed data and you need to come up with a rule of thumb, my guess for the project you just described, you probably want to try an aux lane.
Oh, aux lane is better.
You'd probably want to pick the component of the project that would capture most of the benefits.
Oh, I see.
But again, it'd be better if you could run a quick microsimulation model.
Yeah, because we are in forecasting unit and we just started using the BC tool, so we don't have the expertise to what you just said about microsimulation.
Right.
So I understand. So I think we are better off taking just aux lane, even though it's the whole interchange and everything inclusive. But aux lane would reflect the BC more appropriately.
That's right. Now,
Okay.
if there are some changes to the interchanges, to the ramp itself, then you might want to look at a freeway connector. And what the freeway connector is doing is it's asking you for inputs about what the current conditions are, and then it has a lookup table for a Leish weaving analysis. And so that may work too. It just depends on the specifics of that.
We are adding lanes to the connector both ways, like 99 and 120, for example.
Okay.
If we are expanding the connector from one lane to 2 lanes, And in doing that, we are adding aux lanes, and we are also expanding all the other direct, diagonal off ramps, on ramps, expanding them from 1 to 2 lanes. Eric, correct me if I'm wrong. Yeah, so.
Okay. So this is a good example of where you can have some complexities in projects, and it is difficult to pick the right category, if it's not a simple project. And I think offline we can probably talk about what's the right way to model that particular one. I did want to go over a couple more types of projects that we have. And the other thing I was going to say is I'll keep about 5 or 10 minutes after this for more questions. And also, we'll put on the parking lot any other questions and take care of them at the end of the day if there are additional questions.
One quick question. Can we put in the parking lot so CalBC will assist to assess better management of the system? Maybe some metrics coming out to show that?
Sure. So the other kinds of improvements that we have a number on the transit or rail side, passenger rail, light rail bus projects, bus rapid transit projects that may have dedicated right-of-way. And we also have a highway rail grade crossing algorithm that actually a number of local agencies in California have used as part of Tiger and Infra grant applications of the feds. For the operational improvements, these could be physical operational improvements, or they could be TMS, Transportation Management System, ITS type improvements. So on the physical side, we do have auxiliary lanes, freeway HOV connectors, HOV drop ramps, on and off ramp widening, and then anything to do with conversions of HOV lanes or HOV to hot lanes. You can argue whether that's an operational improvement or not, but we have it under that category. And then on the ITS, TMS side, we have ramp metering, incident management, traveler information, arterial signal management, and then a couple of transit ITS projects as well, transit signal priority, and also AVL, automated vehicle location systems. So these are generally the kinds of projects we handle, and for each of these projects, we conducted research, tried to find the best methods we could to help us come up with those rules of thumb for how you analyze the project. If you have your own data, you already know the benefits, you don't have to use the rules of thumb. You can override the values in CalBC, or you can use CalBC Corridor if you're using data from another model. So this is the user interface as it's set up for CalBC, and this is very common across all the models. It's set up to be a 1, 2, 3 process. So 1, you enter in your project information about the specific project. In the background, the model, it's all linked formulas. It calculates what it will use as the inputs to the benefit cost calculation. And those are presented on the second page, which is the model inputs page. You can review those. If you have better data, you can override it. There's a little comment section where you can say why you overrode it. Hey, I have traffic counts. This is wrong. And then there's a results page which presents all of the different benefit cost measures. So, a lot of people focus on the BC ratio, the benefit cost ratio, but there are other measures, as Ryan was mentioning, net present value, payback period, internal rate of return. They're also reported. One of the updates we did for the SB1 program is we worked with ARB to update that results page so that it reports all the emissions. Because when we calculate the emissions benefits, we're already estimating the emissions. We're estimating the amount of the emissions, and we're putting a monetary value on it and including it as part of the benefit cost calculation. So we worked with ARB to make sure they were comfortable with the methodology. We've checked all the emissions rates within the model, and so when you do your SB1 application, the emissions rates that are reported on CalBC are the ones that you would report for your project. It reports emissions in tons, and it also reports a value of each emission category as well. After these 3 sheets, then in the back of the model you have parameters. But in the intervening pages, you have a number of other sheets that are the detailed calculations for each of the benefits. And there's a separate sheet for every benefit category. So if you want to look at how travel time benefits are calculated, you click on the travel time benefit page. It has step-by-step how the benefits are calculated. And sort of the basic layout is every benefit's calculated in a table, has 20 years of benefits. You start from the left that has, here are the inputs, and it kind of works out the logic of, from speed and volume, I'm able to figure out what the difference in travel time is. Here's the difference. Let's apply a value of time to that. Here are the travel time benefits. So it walks through that table. At the same time, if you go down, there are a series of tables, and they're broken out by different modes or time of day. So there'll be a separate table for, say, the HOV mode or the non-HOV, and peak period and non-peak period. There'll be a separate table for buses. And all of this is then on the right, on every detailed page, aggregated, so you can see in a column how all the benefits stack up. And so if you're having trouble understanding why you're getting certain benefits, the way I would diagnose it is go to the results page, figure out which kind of benefit you're having trouble with or confusion about, go to that specific page. Again, let's call it travel time. Go to travel time. If you go to the right, it has the summary of all the benefits, and you can look down and say, that doesn't quite make sense. And that'll help you diagnose why you may be getting counterintuitive results. And it may be the right result, or it may be something that you need to change in the inputs, that there is an error there. Typically, people don't look at the detailed pages. I mean, you can really focus on just 1, 2, 3. But if you want to get into the details of it, you can look at the other pages. They're all there and open. One other page I should mention is the final calculations page, which is at the second to last page in the model. The final calculations page is where it takes all of the benefits of the different benefit types, takes the travel time benefits, the vehicle operating cost benefits, the emissions, the accident benefits, and lays them out and calculates all the benefits that are then reported on the results page. So it's sort of the aggregator page. So this is a blow-up of what the project information worksheet looks like. And this is, again, just for the CalBC regular model. This user interface is the same across all the models. I mean, it'll look a little different depending on which model you're looking at. But for each model, it's broken out into boxes that are labeled 1A, 1B, 1C that capture different kinds of data. So for the CalBC model, box 1A is just some basic housekeeping project information data. So you're entering in information like where is this project located? Are you entering in one-way or two-way data? How long is the peak period? In box 1B, it's more detailed highway design and traffic data. Box 1C is where you'd enter in the accident data, and then box 1D is used if it's a transit project. And the way that works is the benefits are calculated from the inputs in box 1D, but if you have modal diversions, then you can enter in data on the highway side and the transit side and capture that diversion. I'd like to do questions at the end, I think. Yeah. And then box 1E are project costs, and that's where you'd enter in all your life cycle project costs for the project. The other thing to note on this screen is that there are different colors. So there's green, blue, and red. And that's to kind of give you an indication of what these cells are. If it's a green box, it's something that you as a user just enter data into. If it's a blue box, that means it's something that's calculated from something else that you've already entered. You can type another number on top of it. You don't have to keep the value that's in there. It's just set up that way to help you. So for example, one of the boxes is what is the forecasted future ADT in the build? It's coded blue because what it does is it references the no build and says the ADT in the build and the no build will be the same. So whatever you type in the no build, it automatically puts in the build. If you have induced demand and you want to put in a different ADT, you just type that ADT on top of that box. So the blue boxes are there to just help you. It's picking things for you so you don't have to enter as much data. But you can enter data into any of these boxes. The red boxes are default values. And so, one of the key default values when you get to a highway project is the average vehicle occupancy, how many people are in each vehicle, because that really drives the travel time benefits. And there is a default statewide value that is in the CalBC tool. It's from the statewide travel survey. But AVOs vary by region. They vary by corridor. And so if you have specific AVOs, you would go down there and you would change that. So, I mean, you shouldn't shy away from something just because it's a red box. That means don't touch it. It's just to give you kind of orders of magnitude. Green boxes, you have to put an input in there. Blue boxes have been calculated for you to help you out, and the red boxes are default values. So this is the project data page blown up a little more. The only other thing I wanted to mention about this page, I did kind of cover some of the boxes, and if people have questions about specific boxes, we can go into them. But there is a little gray button at the bottom of the page, and it's labeled Prepare Model for Second Road. And this is the one macro that's in CalBC. And frankly, we didn't want to put a macro in because we wanted it to be completely transparent. But we put this macro in because what it does is certain projects actually require you to enter in data for two different roads. So if you have a bypass project, you've got your original route, but now you also have the bypass, and you have to put in data for both. And so what you do is you enter in data for the original route, click that button, it saves your results to date, clears out the inputs, and then allows you to enter in the data for the second road for the bypass. It does the same thing for an intersection project where at the intersection you've got one road, so you enter in the data, then click the button, and you enter in data for the second road. When we added the truck-only lanes, we also used this button because the way we're modeling the truck-only lanes is treating the truck-only lanes as essentially a bypass for the trucks around the existing route. Think about that truck-only lane. Even though it's physically adjacent to the existing lanes, it's operating as a different route going the same way for the trucks specifically. So you would enter in data in the no-build for the existing route without the truck-only lanes. Then you add in the truck-only lanes. It assumes the trucks divert to that, and then you enter in information about the truck-only lanes. And so that's basically what you do for this macro button. But if you have questions as you go through, please feel free to ask questions of the economic analysis branch. The other thing is there's a user's guide, and the user's guide has kind of a step-by-step discussion of how to use the model. This is what the project cost page looks like, and it's the same in all the models. So on the project cost sheet, it's intended to capture the life cycle costs of the project. So the top columns, it has up to eight years of entering costs. If you have a project that takes more than 8 years to build, come see us. We'll figure out how to handle that. But we anticipate up to 8 years of capital construction. It's broken out by project support, right-of-way, actual physical construction costs. You don't have to break it out in that detail. I mean, the way it's calculated, it matters which year you put it in, but it doesn't matter which category you put it in because it's just rolling them all up. I mean, this is really just intended to be more of an accounting worksheet for you, just to kind of help you keep track of your costs, just based on how you might have them broken out. I should note that all costs, and this is kind of an important caveat, all costs in the CalBC model need to be entered in thousands. So if you have $1 million, you enter it in as 1,000 because you're entering it in thousands. So take all your numbers and take 3 zeros off them.
So those two questions, what year dollars are you talking? Do we enter it in?
So you do want, that's a good question. I'll go ahead and address that now. So the question is, what year of dollars do you enter into the model? You'll oftentimes have year of expenditure dollars, or you might have current year estimates. The right dollars to estimate in would be 2017 dollars. Bring it back into constant dollars to today. The examples we're going to show to you today are in 2016 dollars, and that's because the parameters in CalBC on the benefit side are based at 2016 dollars. I don't think it's a problem comparing 2016 benefits to 2017 costs. If it causes great heartache for people, we can update the benefits values. But I think we're okay just using 2017 dollars, and I think it'll make it easier for everybody in submitting their applications. In addition to the upfront costs, the capital costs, the right-of-way costs, the project support type costs, or on the transit side, maybe it's capital equipment, buses, fixed rail expenditures. There are also subsequent costs, ongoing operating and maintenance costs, rehab costs. Those are the kinds of benefits that you'd want to report in these columns down here at the bottom. And so it's a 20-year analysis that CalBC is doing. It's calculating benefits going 20 years forward. So you'd want to enter in 20 years of cost. And ideally, you would enter in as well what rehab cycle you'd have and those subsequent rehab costs. And those would be entered in here as well. There is a little note that the model will do. It says right here, must enter a cost. And that's because when we took the snapshot, we'd selected the project would be built in 1 year. So the model is prompting you saying, well, you should be entering data for that 1 year. And if you pick 2 or 3 years, say 3 years, you would see this little note on the first 3 rows, reminding you need to enter a project cost in each of those 3 years. And the timing of those costs do matter because when you do a benefit cost calculation, everything's being discounted back in time. And so depending on how your project is structured, it will affect the costs. Do you mind doing the questions at the end? I will make sure I keep some time for that. So this is the model input sheet. This is where it pops up the results of the model. The blue cells show what the model calculated. You can override those in the green cells. And then the model uses the gray cell. And the gray cell is simply, if you type something in the green cell, we'll use that. If you didn't, we'll use what the model was calculating. And it has a little place on the side here where you can enter in some notes about why you changed that particular input. You can also check the accident rate calculations, the before and after. And then there's one box over here on the side, the annual person trips box, which is really just a reference box. And it allows you to track your person trips if you have a hotline project. Because anybody who has worked on a managed lane or a hotline project, it becomes very complicated. You have to know how the average vehicle occupancy is shifting as you attract people to the HOV lane, which is now a hot lane, and you're charging a toll. And because you're allowing people on where you charge a toll, it changes the number of people in vehicles. And so you have to put in the right AVOs in the build and the no build to do the calculation. And this gives you an estimate of the number of trips based on the ADT and the AVOs that you've entered so you can make sure you have the right number of trips that have been entered in the model. So this is just a blow up of that screen, and you can see, we show with the project, and there's a separate table without the project, year 1, year 20, volume and speed by the different modes in both the peak period and the non-peak period. And this is all data that's been calculated based on some simple inputs that you've entered into the model. And then this is what the results page looks like. On the left-hand side, these are the benefit cost results. Costs, benefits, net present value, benefit cost ratio, return on investment. And then these are the details of the benefits. They're separated between passenger and freight benefits. You can see the contribution of auto versus truck. You have the total over 20 years, and then there's the average annual, which is simply the total divided by 20. We took the total benefits and annualized it by dividing by 20. There is a measure of effectiveness or performance measure, person hours of time saved. And then in addition, these are the updates that show the emissions that are being calculated. Tons, 20 years divided by 20, the annual tons, and then the value of those tons. You can also turn on and off benefits. So you can tell it, nope, I really don't want to include the vehicle operating cost benefits. Click no. No, I don't want to include induced demand or reduced travel. Click that off. And so you can adjust these. I think most people, when they're filling out an SB1 application, are just going to keep all of these on yes. There's going to be no reason to turn them off. This is just an example of those detailed benefit calculations that I explained earlier, where you start on the left, the benefits are calculated, and then the values. As you go down across the tables, this is the peak period HVO versus the peak period non-HOV table, and then there are subsequent tables below. And to the right, here are some transit tables. In this model and in every CalVC model, on the second page of the model, after you start up and there's a title page, we have an instructions page. And it's actually set up so you can print it out, and it will be like a little booklet that you can just walk through, and it gives you step by step what the definitions are and what you're supposed to enter in each cell. And there's documentation available. So there's the user's guide. The user's guide also has more detailed step-by-step analysis, explanations of the tool. It also has examples in there. I think there are 3 or 4 examples in the user's guide now. Since we can do 20 or 25 different project types, we just don't have them all in there. But we have a couple of different representative project types as examples. And in addition, there's technical documentation. And so on the Transportation Economics Branch's website, you'll see all the technical documentation. There are 4 volumes of technical documentation. I mean, this model's been evolving for 20 years. It's a pretty heavy read. I mean, it's getting close to 1,000 pages now. But any project type you want, you can go in there, you can see exactly what the methodology is and how it's calculating that project type. The most recent volume is volume 4, but they're all online. So what I was going to do is go through a quick demonstration of the tool. And I know we said we were going to go through 10:30 and then take a break. So what I'm going to do is go through at least one of these examples, and then we can take a break, and then we'll start up again after that. So the first example I wanted to show is an HOV project, and this is kind of a hypothetical project, kind of not. We stole an example we used for District 3, Sacramento, several years ago. So this is US 50. The data is old. The project costs we've changed. So don't believe that this is really a real project. We've just tried to come up with something that is believable and credible as just a hypothetical example. But basically, you have a project where you currently have 8 lanes. There's a lot of congestion that's occurring in this part of the corridor. It's pretty close to free flow as you go towards Folsom. And what they're doing is adding HOV lanes. We're not adding any more general purpose lanes. We're just adding in HOV lanes. So the first thing we do is we enter in data. We pick that this is an HOV project from the project type list, and we say it's in Northern California. And this project location matters because it's used for calculating the emissions benefits. The way emissions are calculated and monetized vary depending on where you are in the state because the affected populations vary across the state. Then you enter in the length of the construction period, how many years of funding there is going to be, whether you're entering in one-way or two-way data. Most people are entering in two-way data. We are here. And then the length of the peak period. So the peak period in this corridor we say is lasting 5 hours. We then enter in data about the project itself, about the highway design. So it was an 8-lane project in the no-build and also in the build. We added 2 lanes for the HOV lane. It's going to have an HOV2 restriction on it. The free flow speed is 65 miles an hour. So it's now going to use these number of lanes and the free flow speed and use a BPR curve or a demand to volume relationship that is also used in travel demand models to estimate the speed on the corridor. And then you enter in the segment length. So this is a 7-mile segment. Now, typically what you want to enter here is how much of the corridor is impacted. Because, if we go back to this map, I mean, the corridor itself, you could say it's 13 miles long. What you really want to focus on are the 7 miles that are going to be impacted by the improvement. And so if you are working off project reports or project documents and they have a defined project area, that's what you would enter here. But if the impact of your project is a subsection of that, then you'd want to override this value where it says impacted length and put that shorter length in there. You can enter in ADT in the current year and in the forecast year, and then it calculates the intervening ADTs in year 1 and in the build year, and will interpolate what the ADTs are growing forward during the life cycle of the benefit cost analysis. This is our HOV traffic, and the 2,800 sounds like a really big number. It's because, if you remember on the previous slide, we said that we were entering in two-way traffic. So this is actually the number of HOVs in both sides of the freeway. So it's actually 1,400, we're saying in this case.
So isn't 1,400 kind of underutilized? Isn't it usually like 1,700 per lane per hour?
Yeah, I mean, and you could have 1,700 for a particular HOV lane. This particular example, we put in 1,400. But I mean, what you're supposed to, this is not the capacity. This is the actual volume that's being used on this corridor. And then you enter in the percent trucks, and the default value in the CalBC model is 9. For this particular corridor, we measured 4. So we put in 4% trucks. And then the rest of the data we didn't change.
So how come you have 2,800 in no build when actually the HOV lane is going to be in the build? So is that the volume of 2,800 vehicles two-way in a no build project?
So the question was why we entered in 2,800 in the no build for an HOV lane when there wasn't an HOV lane in the no build. The way that CalBC is looking at the benefits is wearing the hat of an economist. And so we're looking at different types of users, not where they're traveling. And so what you should be entering here are the number of HOVs, the number of high occupancy vehicles that use the roadway, whether they have an HOV lane available to them or not. So if there's going to be a no induced demand, I mean, if the HOV lane does not cause more people to use this corridor, you'd actually expect to see the same number in both of these. But when we are calculating the benefits, the model is going to recognize that this 2,800 don't have an HOV lane, and their benefits are going to be their travel time is going to be the same as everybody else in those general purpose lanes. And that's part of the calculations. It knows that.
So I have a bunch of questions, and I can wait until then, or we can talk offline on this input parameter, because this is a very key input, the volumes.
It is, yes.
I can wait.
Okay. Yeah, I'd like to kind of go through the rest of the example and make sure, we have some time to go to the other models too. I have to say, one of the challenges we had when we were designing today is knowing the right level of detail to go to, particularly since there's so many different kinds of projects that people can submit as part of the SB1 program or for other projects as well. So we're trying to give as much of an overview as we can of all the different tools. So yeah, if you don't mind holding that question to the end. So this is where you would enter in accident data. In this particular project, we entered in actual accident data. These are counts from a TASIS Table B that the local district ran. And then we looked at changes in the average accident rate, and we used lookups of standardized accident rates from the no build to the build. And what you're seeing here is that the accident rate goes down when you build the HOV lanes, and that's just part of what the statewide average statistics are telling us. And from this data, it calculates the safety benefits. The project cost information, it was $205 million over 3 years. We knew the separation of the project support and the right-of-way, but we didn't know the separation on the construction side. So we just divided by 3 and spread it across the years. You probably will know more. This particular example, we didn't. If you don't, dividing by the number of years of construction is a reasonable assumption. And we entered all costs in constant 2016 dollars. So this is the result of the project. It had a benefit cost ratio of 4.9. And the overall, you can see, for about $200 million in project costs. And you'll notice this number, by the way, is smaller than the project cost number we entered over here. And it's because the $205 million with discounting is $198 million, because we do discount the benefits over time and the costs as well.
So how come you don't have any costs in the operation and maintenance?
For this question was why we didn't have any operations and maintenance costs. For this particular example, we just didn't put any in. Obviously, one would put operating maintenance costs if they're available. So that's kind of a quick overview of how you would do an HOV project. What I'd suggest is let's take a break right now, and when we come back from the break, I'll go through a light rail project, then answer some questions. I'm going to go ahead and get started again. What we're going to do is go through the light rail example and then maybe address a couple of questions, and then we'll move on to the AT tool. And just to remind everybody, I mean, we do have time at the end of the day today, too, to answer all kinds of questions that aren't covered throughout. So the light rail example is a hypothetical project where you have a light rail, you're making track improvements. They're actually pretty low-cost track improvements that are going to reduce travel time for transit passengers. So what we're entering in this project is we're picking that it is a light rail project. And then this happens to be located in Northern California. And it's going to have a 1-year construction period. They're very small track improvements. They're simple, so it's only 1 year's worth of data. And for this particular analysis, we're entering in one-way data. So we're only making improvements in one direction on the track. And again, we're assuming that the peak period is 5 hours long. So I'm going to jump over that slide and come back to it. When you enter in the transit data, that's in Table 1D. You enter in information about the annual person trips, how many people are actually using the light rail services. And you enter in information in the no build and the build for year 1 and year 20. There's an assumption here of what percent of the trips are occurring during the peak period. You'll see it's a red cell. This is a default value. And it's actually populated based on your selection of the 5-year data. And this kind of gets into what the model is doing on the highway side and on the transit side. It uses data from the statewide travel survey. And depending on the number of hours you pick, it picks how many hours are assigned to the peak period or the not peak period. So you can manually override this and change the percent that's in the peak period. And then we're also assuming that if there's any change in the trips, and you can see there is a change here, we're going from 9.5 million trips. And by the way, this is annual, not daily. 9.5 million trips in the no build to 9.7 million trips in the build. So we have another 200,000 trips occurring annually. They've got to come from somewhere. And so the default is that 100% of those people are coming from cars. Now, they may come from another transit mode. There may be something else that's going on. So you could change this percentage. But we're assuming it's 100% from the auto mode. And then you can see down here, we see that we also think that this project is going to reduce accidents on the light rail. I mean, the accident rates are already very low. But the engineers are estimating that it will reduce the accidents by 1%. So we put in 1% accident reduction factor. The model is going to look up the average accident rates for light rail in the no build. And in the build, it's going to reduce that by 1%, and you'll get benefits for having reduced the accident rates. Then for the average transit travel time, this information would be information you'd get just from published schedules. I mean, you can look at the published schedules and see what the travel time is on the corridor. If this isn't a fixed guideway system, it's bus, and they're constantly getting off schedule, maybe you would update this with a different number that reflects the actual operating conditions. But generally, you just want to go to published schedules. And because of these improvements on this particular project, you can see that the travel times have improved between the no build and the build. So people who are already taking light rail will get benefits because their travel time is shorter in the build conditions. But something may happen for these people coming from the highway. And the way this particular project was constructed is that the travel time on the highway currently is faster than light rail. So they don't get any benefits initially. But when you get to the 20-year conditions in the peak period, the travel time on the freeway or on the local roads, this is actually a local road example, are so slow that you're faster to take the light rail. And so for this 100% of the 200,000 people that are now taking light rail, once you get into these forecasted years, they're starting to see benefits as well. So I'm going to go back a slide. And on this slide, this is where you enter in information about the highway. So if you wanted to be complete, you would enter in information about your roadway network or parallel road that you're attracting people from for this light rail project. And you'd have the complete ADT. In this example, we were a little bit lazy. We didn't do that. All we did is we entered in actually the number of people that were, put in a number big enough that it had values, but we didn't let the BPR curve, the volume to demand curve, calculate a speed. We just put in a low enough number that there were some people using the roadway, and we manually put our free flow speed as the actual speed people are doing on the roadway. So on average, we found that on the arterial network, people are traveling at about 25 miles an hour. Because this is a very low volume compared to the capacity of the roadway network, it's going to say they're traveling at free flow speed, which we set to be the speed we wanted. So that's a trick you can do. Alternatively, if this is a corridor where you see a lot of shifting occurring over time and you want to calculate the peak versus non-peak differences, then you wouldn't need to know the full ADT and you'd need to know the number of lanes so it can do a BPR curve calculation.
Just a real quick question. I mean, I think we talked about it before, but when you have a situation where there's not one corridor that it's switching, that's a real simplistic.
Just to repeat my question, it's simplistic that you just say you have one alternative route that this is taking all the trips from, rather than a more complex system where you have numerous different travel patterns that are being affected.
Yeah, and so there was a question during the break that no one on the webinar, probably no one else in the room heard, but of a particular example of a project that would involve people using the transit project as an alternative to other transit modes and to the highway as well. So it was a pretty complicated shifting that would occur. And that's an example of a project where CalBC it's probably going to overwhelm the capabilities of CalBC unless you want to do a lot of off-model calculations and get these numbers to be exactly right so that it reproduces what you calculated. You can alternatively, and I know this is part of the CTC guidelines, they encourage you to use CalBC, but if you can't, then you are able to use other benefit cost methods. So if you do your own calculation outside of CalBC, what I would suggest you do is copy the parameters page from CalBC to your own spreadsheet and then reference all the variables so you're using the same discount rate, you're using the same value of time. That's going to be more expert user if you need to do that. But it's a complicated project to begin with. So we also enter in project cost data here. The project costs are $11.2 million. You'll notice it's 11,200 because, again, we're entering everything into thousands, so we chopped off 3 zeros. And there is a note here, enter costs in thousands. So if you get a really wacky benefit cost ratio that is really, really low, the first thing to do is go back and say, did I enter my costs in thousands? That could be the problem. And then this is the result. We got a benefit cost ratio for this project of 2.7. The biggest set of benefits are the travel time savings, although there were some accident cost savings. That's due to that 1% improvement in accidents. You also see some vehicle operating cost savings, and that's due to those people that are shifting from the highway mode to transit. Now they're saving wear and tear on their vehicles, buying fuel. Another cost that someone brought up to me over the break was parking costs. That would be something else you could save. The model doesn't automatically calculate those, so if you did want to include parking costs, you'd need to add those to your benefit cost calculation. The way that you would add anything to the benefit cost calculation is to go to the final calculations page of the model. And I'm just going to do something dangerous here and go into the tool and just show you that final calculations page so you can see it. This is the CalBC model. And if you go to the final calculations page, this is where it summarizes all the benefits. So here are the travel time savings, the vehicle operating costs, the accident costs, and the emissions that have been calculated from all of these detailed pages. They're summarized here. And this spreadsheet then just takes everything and calculates all the various economic values that are then reported on the results page. So if you have some additional benefits that you've calculated off model and you want to include those in your benefit cost calculation, you could enter them in these additional green cells. And they would be included as part of the benefit cost calculation, the net present value calculation. They'd all be added in. Obviously, if you were to do this, you'd want to document it. You'd want to justify why you added additional benefits and how you calculated those additional benefits, because I'm sure that'd be part of the evaluation that CTC would do.
You're just saying, just insert a row.
Insert a column, title of what it is, and add the benefits.
I would actually do something as simple as just going here and deleting these. Sorry, this is not my computer, so it doesn't have the same controls that I'm used to. So, I'd add something here like parking costs, and you can just put in your numbers, or copy and paste them in, and it'll include those. Okay, so that was the light rail example. Are there any kind of quick hit questions people wanted to address? I think some really specific project questions, maybe we'll hold those to the end, but are there any sort of burning questions that you think we should address right now?
My question is mainly on the input of volumes. When you take base year, no build, and then build, do you usually use a model, trial demand model volumes, or do you use actual ADT counts?
Well, so for
what do you prefer?
For the current conditions, you'd probably get that from your current counts. And for a forecast, I mean, if it's in a rural area, then you probably have some kind of growth factor that you're using. If it's in an urban area, you probably take forecasted traffic on that corridor from a travel demand model.
Okay.
And if your corridor is not included in the travel demand model, maybe you'll use a regional growth factor from the regional planning agency, or from routes that are nearby.
Sure. So the problem that we have San Joaquin SJCOG model, and that model being capacity constrained doesn't really give us much volume differences between the base and the forecast, because it's capacity constrained, and so it just pairs the peak.
Yeah. Well, and I think this is where local knowledge about the project is. You're going to have to be able to estimate the demand for that
so if we apply a
corridor.
2% rough growth factor and then jack up the counts by that much amount for future, I think that gives us some realistic demand.
And in that case, you just need to be able to justify how you came up with those demand figures.
And then the volume. What happens is that this route, for example, 205, that corridor is so heavily traveled and it has a very peculiar directionality. So morning you have westbound, it can be anywhere from 3 to 5 hours of peak. Mm-hmm. Evening is 5 to 6 hours of peak. And so if you take the ADT two-way, it's not going to give you a favorable BC because it...
And so this is an example where if you were to use the simple sketch planning tool, you would probably want to model using one-way data, because remember, you can select one-way or two-way. Model it with the one-way data, save the results, open up another spreadsheet, model the second way, and that final calculations page I showed you, just copy and paste one of the sets of values into the other one, so you have a total benefits, and it'll add all the benefits up, and you have the whole project then. But the project you're describing is one where, if you have access to the travel demand model, it may be a better way to go to run the travel demand model, because then you can really get sort of the route shifts that are going on and the real growth in the future, and then post-process that using CalBC Corridor, using a different CalBC tool.
Okay. Thank you.
Sure. So I think what I'm going to do is jump onto the active transportation tool. And if there are other questions about this model or really any of the other models, we've got some time at the end. The active transportation tool was one that was developed. This is actually the second generation of this tool. It was developed for the active transportation program and to meet the program guidelines. And so there was a first generation tool that was testing out the concepts of active transportation. That's been refined now, and this second generation tool has been developed that's fully compatible with all the other CalBC tools. So it's using the same value of time, it's using the same discount rate, it's using the same parameters page. You'll notice it's called CalBC AT version 6.2. You'd think you'd see a number of 2 there because it's the second generation tool. It's 6.2 because that's the same number we're using for all the models. We're kind of like Microsoft. We're bringing them all up to whatever number we want, and we're calling it 6.2. So all the current versions of any flavor of CalBC that you're looking at should say 6.2 on it. That's the current version. Like the other models, I mean, it's supposed to be not a black box, intuitive. Admittedly, active transportation projects are very complicated to analyze, and the research in this area is fairly new. There really aren't a lot of benefit cost tools out there that do active transportation. There was one that was developed under a National Cooperative Highway Research Project, an NCHRP project, that had been on the web for a while, and then it got pulled. They decided they didn't like the methodology under it. The United Kingdom are kind of leaps and bounds ahead of us in benefit cost analysis, and they have a module that they do. They actually have a very standardized approach that they do for benefit cost throughout the whole country, and it's very prescriptive. So over the years, we actually know the economists at what's called the TAG group at the Department for Transport in the UK, and we share ideas back and forth with them. And so we looked at their active transportation methodologies. We also looked at some other methodologies, some recent research, and that's how we developed the methodology that's here. But really, this is a fairly new and groundbreaking model because there really haven't been a lot of active transportation models out there. So we do welcome comments in the model too. So if there are things that it's doing, there are benefits that it's not capturing that you don't think are right, let us know. I mean, you know, we constantly are evolving. And when you compare this model to the CalBC model that I just showed that has evolved for 20 years, we haven't answered almost every question on that model. For this new model, it's a work in progress. And, I mean, I don't mean to say that it's a bad model. It's a state-of-the-art model. It's just an evolving model. And so, you know, we are looking for any feedback you have. So like the other models, it's an Excel spreadsheet. It has that same sort of 1, 2, 3 process. You know, you provide some input data. It calculates some numbers that you can check, shows you the results. Exact same setup as all the other models. It uses the same discount rates. The types of projects that the model covers is a combination of infrastructure and non-infrastructure projects. This is in response to what's included in the ATP program. The Active Transportation Program has infrastructure projects where you're building something, and then non-infrastructure programs where you might spend money on like an educational campaign, you know, safety projects, or you need to encourage ridership, safe routes to school. So we can handle both kinds of projects, although there is much more research that was available for infrastructure projects. So for infrastructure projects, we can calculate a benefit cost ratio. For non-infrastructure projects, we calculate a cost effectiveness ratio, which is kind of check the box on all the things you'd like to get out of this project and compare it to the cost of the project. So it's not quite a benefit cost ratio, and that's frankly because there isn't as much research available for these kind of educational campaigns and the other sort of non-infrastructure types of projects. I did some work under an NCHRP project for the National Academy of Sciences where we're looking at the effectiveness of highway educational campaigns. So, you know, when you have like sobriety checkpoints or media blitzes on different kinds of highway safety projects. And for something that's been around for years and years and is across all the states, there wasn't a lot of research there either. So these non-infrastructure type projects is an area of research. It's not an area where we can apply yet. We include two types of modes, both bikes and pedestrians. I do feel like in some of our documentation we've given the pedestrian mode short shrift. We talk a lot more about the bicycle modes. But, do be advised, pedestrian modes are included in this tool as well. We can handle sidewalk projects and other kinds of projects that would affect pedestrians. We also tried to do some, if you look at what people have done so far for these kinds of active transportation projects, they've focused on just upgrading facilities. I have a facility, I make it better. I add a bike lane, I improve the signal timing for pedestrians through the traffic signal. What we try to do is take a more holistic approach and realize that a lot of these projects are gap fixes. Maybe you already have a bike lane, and this is just filling in those last couple of mile gaps in your bike lane program. And so what we have is you can upgrade an existing facility, you could build a totally new facility, or it could be a combination of you already have a facility in place, so you enter in information about that facility, and you're adding to it, so you have this new facility as well. So it's a combination of upgrading the existing facility and the new facility. And then we also separate out the benefits of safe route to schools versus non-safe route to schools. And this is partly just addressing some of the requirements of the ATP program, just recognizing different kinds of benefits. But when you look at the benefits overall, the benefits for the school kids and the benefits for everybody are all added together. But you can see the school children benefits separated out. So these are the types of benefits that are included in the active transportation module. Journey quality, which is a new kind of benefit, and I kind of described this at the beginning with the CalBC model, that journey quality is really meant to be a trade-off between travel time and safety. It's a combination of reasons of why someone would take this route. And it's based on some research that we actually found in San Francisco, where they've done a lot of studies on why people are trading off for different kinds of routes. And so we're actually able to calculate what an economist would call a demand elasticity that allows you to see why people would shift and then what the value of that shift is. We then also calculate, now I'm going to jump over these two for just a second, I'll come back to them. We then also calculate accident and emission cost savings to automobiles. And the idea here is that if you encourage people to take active transportation modes, you get them out of their cars, then there are going to be fewer auto accidents that they're exposed to. So there's a benefit to that. And there are going to be reductions in emissions. They're out of their vehicles, you no longer have the emissions associated with those vehicles. In addition, there is a health benefit due to being more active. And so if you move from an auto mode to an active transportation mode, then there are two kinds of health risks that are affected. One's more short-term, which is, hey, there are less sick days, you're showing up in your job, you're productive because you're just healthier. That's kind of a short-term benefit. The longer-term benefit is it reduces mortality risks, what people in sort of the public health sphere call QALYs, or your quality of life. It's a way of calculating how your mortality has changed over time. We can put a value on that. And so looking at the lost productivity and improvements in your length of life, you can calculate these health benefits. And so these are the primary benefits, but then there are a few additional benefits. So as I mentioned with journey quality, it's intended to capture both the travel time and the safety benefits, but we recognize that there's certain places where it doesn't capture those benefits. So if you make a specific improvement at an intersection where you have made it safer to cross that intersection, maybe you've changed the signal timing, you've put in some striping that helps you get through the intersection, there could be travel time savings or safety benefits specific to that intersection, and we view that as not double counting with what we're already capturing in the journey quality benefits. So we can add in that information and capture some additional travel time benefits. Likewise, the research on the journey quality didn't capture the benefits of, say, building a sidewalk where there was no sidewalk before. So for the safety benefits, there is a safety improvement of people not walking on the road but actually using a sidewalk. And so as part of these safety benefits, we can look at the safety of improvements at the intersection or improvements on sidewalks. So these are additional benefits The reason I wanted to separate these out and talk about them separately is some people that have looked at the model have gotten confused and said, well, wait a minute, these travel time savings don't capture all my travel time savings. And what we want people to recognize is that they're captured under journey quality. It's supposed to capture those travel time savings and the safety savings. These are just additional travel time savings and safety benefits on top of those. So the user interface for this model is identical to all the other CalBC models. I mean, we have a title page that pops up and says, hi, this is the model. There's an instructions page that, again, is a brochure that you can just kind of print out. It's a booklet that you print out. I don't know how many pages it is. It's about 5 pages. Is it 6 pages? 6 pages, double columned. You can print it out, and it makes a nice reference guide, and it should be able to tell you cell by cell what you need to do to use the model. And then this model has one additional page called definitions, because there are a lot of concepts in the active transportation world that are new to some people. And so we've tried to put in some definitions that are either common definitions for bike ped or definitions that are specific to this model that you need to know how we're interpreting things within the model. So that page is also set up so you can print it out and it'll give you a list of all of these definitions. And then there are the inputs pages. And again, it's sort of 1, 2, 3. Although the thing that's different here is that we have 2 inputs pages because there are a different set of inputs for those non-infrastructure program projects, the media campaigns and other sort of non-infrastructure projects, where we have a different set of inputs. So we've split it into a 1A and 1B. And then like the other models, there are detailed pages that show the calculations of every benefit. There's a final calculations page that wraps all these benefits together. And then the parameters page in the back that has all the economic values that are used. And like CalBC and all the other CalBC models, it's the same parameters page. So the CalBC model that I showed you before, it has active transportation parameters in there. It doesn't use them because it doesn't calculate benefits for active transportation projects, but they're in there because it's the same parameters page across every model. If you have an active transportation project, you want to use this model. So this is what the input page looks like. It scrolls down for a bit, and I'm going to go into each of the different pages individually. And then it also has project cost data that you enter. There's that second page for non-infrastructure projects where you enter in information about the non-infrastructure projects. And then that page 2, the model inputs, allows you to check things like number of annual trips, users, travel time miles for bikes and pedestrians, year 1, year 20, in the build and the no build. This looks just like the CalBC model, and it's the same idea. You take some simple inputs, you enter them into those first page 1A and 1B, and it transforms those into inputs that the model can use to calculate the benefits. And then it shows the results. And the results page here looks just like the other CalBC model. The only difference here, and actually I realize this is not the most up-to-date results page, so let me show you that. So this is the results page, and it looks just like the other CalBC models where you have your benefits here, you have your itemized benefits, you have some specific benefits that we're reporting for safe routes to school. That was useful information for the ATP program. And then it reports the emissions. And there was one comment that came up during the break that I wanted to repeat for everybody. There's an SB1 emissions tool, and I think there's a little bit of confusion as to whether you need to run that tool or how does that relate to what the emissions are here. We're going to cover the SB1 tool at the end of today, but the idea is that we've worked with ARB on all the emissions calculations, and each of the CalBC models reports the emissions for you. It reports the tons, it reports the valuation. ARB has reviewed this. These are the emissions calculations that you use as part of your application. So you don't need to run the SB1 emissions tool if you've run your project through a CalBC model. If you have not, and you're trying to do something different, then you do need to use the SB1 emissions tool to calculate your emissions because you didn't have it from a CalBC tool. But the SB1 tool uses the same parameters and emissions calculations as all the CalBC models. So it should be comparable emissions calculations across those tools. But again, you don't have to use the SB1 tool if you're already using one of these models. This is the instruction page. It looks identical to what you'd see in CalBC, but it's specific for this model. And then the documentation you'll find for the active transportation tool, there are two sets of documentation. Just like the CalBC model, there's a user's guide. The user's guide walks through the entire tool. We thought it was really important that this tool had a user's guide because it is a little bit more complicated than some of the other models. It has some unusual or maybe new concepts for some people. And so the user's guide explains everything in the model, and it also works through an example using the model. And if I remember right, it is a different example from the one I'm going to show you today. So you'll have two examples now, one in the user's guide, one you're going to see today. The other thing is there is documentation included in the CalBC technical documentation. As I mentioned earlier, there are 4 volumes in the technical documentation. This being one of the new additions to the CalBC framework is in volume 4. And if you look at chapter 3 of volume 4, it has all the details of how benefits are calculated, what was the research, the literature review that was done to justify why the benefits are calculated that way. So if you need technical documentation, you can go there.
So what would really help is when you have a new version of CalBC coming out, if you could maybe elaborate just highlights, like what are the changes from the previous version?
That's a really good question. And what we've tried to do, the way this documentation has evolved, it started 20-some years ago, and it's grown over time. There used to be just one volume. There was the technical documentation for the original model. Then we did an update, so we added some. We added another volume, and it's kind of grown over time. Every time that we've done a major update, and we've added a volume to the technical documentation, the first chapter of that documentation explains everything that's changed. And so if you go to the last volume first and look at that, it gives you an overview of the latest framework. And that has been, frankly, a time-saving device that then we don't have to go back and change all of those other pages. And we also maintain the history of how things have evolved over time. So the technical documentation provides an overview of the model, explains literature review, descriptions of how all the benefits are calculated. So I'm going to go through an example of an ATP project. And as I go through this example, I'm going to expand on some of those screens that I kind of went over quickly in the model overview. So in order to show a couple of different features of this project, I'm going to show a more complicated example than what you might use this tool for. What we're looking at is a project that has 2 components. We have an existing bike trail, and we're using the word trail generically. It could be a bike lane on a roadway. It could be, a separated bike facility. So we have a bike facility where we're going to upgrade that facility, and we're also going to make some improvements at an existing intersection that's going to improve safety and travel time through that intersection for cyclists. In addition, we're extending that existing facility to go further, and so we're going to have a new facility in addition to what we already had. So the route is currently used primarily for cycling. It is a multi-use trail, but it's not used as much by pedestrians currently. The new facility, we think, because of the way we've connected the facility, we're actually going to attract some pedestrians now to the facility that we hadn't before. And the project provides connectivity for children to local schools. So, there is a safe routes to school component of this project as well. So this is a table that describes a little bit more about this particular example. Currently we have a 4-lane facility. It's being expanded 2 more miles. Sorry, a 4-mile facility. It's being expanded 2 more miles. So now we're going to have 6 miles in total. We're upgrading the existing facility from a bike path to a bike lane. So it previously just had sharrows on the road, and now we're going to have a dedicated bike lane. The additional facility, as we go to those additional 2 miles, is not going to be a bike lane. It's actually going to be a separated facility. I mean, this is a Class 1 facility that's off the roadway. And both the upgrades we're doing to the current facility plus the new extension of the trail is going to include some pedestrian amenities, which we think will attract pedestrians. Overall, it's going to take 2 years to construct this project at a cost of $4.5 million. And this project is going to be located in Southern California, provide connectivity to schools. And there's also an educational non-infrastructure program associated with, a media campaign. As you can see, there are a lot of components to this project. You probably wouldn't build a project that has every one of these components, but we tried to put them all in this example so you can see different aspects of the tool. And, this media, it's an education and outreach program, the non-infrastructure portion. And it's going to cost $1,000 the first year and $5,000 the second and third year to do this media campaign. This is the profile of users. So in the current facility, there are no pedestrians using the facility, 151 cyclists daily. There are a couple of kids that are biking to school, but there are actually more that are just walking to school from the local neighborhood along the facility. For the new facility, for that extension, we're expecting to see another 100 cyclists along that extension, and we're expecting to see 75 pedestrians, and among those we're going to have some children as well. One question that came up as we're developing this tool is, do you use the same values for kids as you do for adults? And this is an interesting area of economic research that no one spent much time on, although the World Health Organization has. And they use a value of half the adult values for children with absolutely no literature review justification whatsoever. So when we developed this model, we decided we didn't want to do that. We're using the same value for children as adults. We said everybody's human. They all have the same sort of likes and preferences, so we use the same values. If you go on the parameters page, there is a separate cell for the adult value and the children's value. And that's anticipating if there's any future research that tells you there should be a different value, we could change that. But that cell references the adult value right now. We use the same value for both. In terms of calculating induced demand or people that are going to start coming and using this facility, we actually didn't have any sort of separate estimates of induced demand. We just have some growth estimates here. And you'll notice that the growth with the new facility is actually faster than the existing facility. So as a result of that, over time, you are having induced or rider shifts growing on this new facility. So by virtue of having different growth rates, we really do have additional people using the facility that have shifted from the old facility to the new facility. If you had separate estimates of pedestrians and cyclists using the new facility, you could just enter that data in rather than using the growth rate. So you can enter it in either way. For the program that's associated with this, it's a 3-year effort. It's a media campaign. They think they're going to reach about 2,500 people. I'm showing you this just so you understand the kinds of inputs you would need for a non-infrastructure project. We think that out of the current cyclists, about 5% of them will be reached through this media campaign. And from the pedestrians, we're only going to reach 1%. Obviously, these may not be realistic numbers for an actual project, but they're numbers we're picking for this example. And we also broke down what the proportions of the target audience are by different age groups. And so if you have a non-infrastructure project, you probably have some of this data. If you haven't worked on a non-infrastructure project, you don't have one of these numbers are probably, rolling around in your head. You don't need these if you're just building a bike facility. This is only if you have a non-infrastructure project. So the way that you would analyze the project, you open up CalBC. It starts with the title page. Every model opens up with the title page that looks like this. And you start with page 1, the project information. So we go to the page and we start entering in what kind of project this is. This particular project, because it has that combination of upgrades to the existing facility plus an extension, a new facility being built, we said 3 in that box. And we entered in information about the existing facility that's 4 miles long plus the extension, that additional 2 miles. If you'd had a project that there's not a bike facility currently, and this is a completely new facility, then we would have entered 2 in this first box. We would enter in nothing in the existing length because there is no existing facility, and we'd enter in whatever miles we or the right length for that new facility here. And vice versa, if you had a project where you've got an existing facility, all you're doing is upgrading the facility. Maybe you have a bike lane, painted bike lane along the curb of a road, and now you're going to go to a full Class 1 separated facility, a bike path. Then you'd probably put a 1 here. You put the length of your existing facility. You leave the new facility blank. So there's a lot of flexibility here depending on the configuration of your project. This project is located in Southern California. It is a Safe Routes to School project, so that means it'll show the benefits for the children separately, in addition to including them in the total benefits. And there also is a non-infrastructure project associated with it, so we clicked that. And it's a 2-year construction period. The second page is where we enter in information about the trip characteristics for users. And so the kinds of trip characteristics you'd enter are information about the facility. And by the way, this should look very familiar to what you saw in the CalBC model. You start with information about the design of the facility, then you start talking about the people who are using the facility. How many of them are there? And so as we walk through this, you can see that we have, on the existing segment in the no build, we had a 4-mile long bike route with those sharrows. But in the build, we've upgraded it to 4 miles of bike lanes. So you can see we moved from a Class 3 to a Class 2. These are left blank because all 4 miles got upgraded. For the new facility, we added 2 more miles, and we added those as a bike path, as a Class 1 facility. And so with this combination of this box 1B and 1E, which are right next to each other in the model, you can enter in information about your existing facility and any sort of new facilities. And if this is a completely new facility, you wouldn't enter anything in this box 1B. Everything would be entered in box 1E. Then you enter...
How come no build has 2? You show 2 lanes in... 2 miles in no build?
Because there was no facility in the no build. This is a new facility. And so the new facility... In the no build, there is no facility. And so the model, you can see this is a gray cell. And I have to admit, I didn't mention earlier, the color coding here is the same across all the models. The gray cell is just an informational item.
Oh.
The model is referencing the sum of all these cells and saying, there must have been 2 lanes that haven't been built yet.
Oh, I see.
But it's just using that for accounting purposes when it calculates the benefits. So it's saying in the no build, there were 2 miles of absolutely no facility whatsoever.
Got it. Thank you.
And now there are 2 miles of a bike path. Along these facilities, we also can tick boxes of pedestrian improvements like street lighting, pavement evenness, having benches, directional signs, and we can show that they're existing or they're built, they're added to the facility. And you can do that for the existing facility or for any sort of extensions or new facilities. And then you enter in information about the travel. And so it's broken down by adults and children. SRTS is Safe Routes to School. And we show the current number of trips and a percent growth, which is then used to calculate the number of trips in year 1 and year 20 that the model will use. You can type in your own numbers if you have counts and forecasts that are different. You can look at both cyclists and pedestrians, and you enter in the same information for the adults and the children, or the same kinds of information for both. And you can do that for the existing facility and the new facility. And we just entered in the information I showed you earlier, so I'm not going to go through box by box. Then we can enter in information related to those travel times and accident savings. Remember, one component of this project is we're also upgrading an intersection. We're making it a little bit safe for pedestrians and cyclists to use that intersection. And so we're entering in a little bit of information about it. There actually were 2 intersections that were improved. Sorry, I said 1. So we entered in 2. And because of this improvement, because we've actually improved the cycle timing for pedestrians, and I don't know if this was, maybe it was an activated signal that we put in, but it actually saved people on average about a minute. So that's what this 1 minute is. And this is part of a state routes to school, so we put in the 1 there. And then we put in information on accident rates. And so this would come from local accident data, and it has information on cyclists and pedestrians that were involved in incidents at those 2 intersections. You put in actual data. And it's broken down by severity, so fatality, injury, property damage. And there's the ability to have the accident rate change over time. Generally, you just keep that constant, but accident rates could go up or down over time, and you could adjust that. And then we put in safety countermeasures. What were things that were done at that intersection to improve safety? In this particular one, we added a countdown signal head. We added a pedestrian crossing. There wasn't one previously. And we also put some signs and markings for the pedestrians. On the next table, we then have this table 1D. In this table 1D, every cell here is blue. And using the color coding in the CalBC work, that means they're all calculated. And this is just information to show you what the breakdown is of trip purpose that are using this corridor. So these are the number of people who are commuting to work. And by the way, it's broken down by cycling versus pedestrian. So the number of people who are commuting to work, taking recreational trips or other purposes, and it's broken out by whether they're cyclists or pedestrians. All of this data came from the statewide travel survey. So we did a special run from the statewide travel survey, got what the average trip purpose is. That's in the back of the model in the parameters page. And this table is referencing all of those. Now, for a particular project, you might recall there were no cyclists and there were very few children. And so these percentages of what percent's being used for other purposes or recreational commuting probably aren't right for this corridor. I didn't change it for this example, but if you have better information, if you've done surveys in the area, or you have some expert knowledge, you can change these percentages. Then you enter in the cost information, same way you enter in cost information for any other project, and you get the benefits. And this has a benefit cost ratio of 1.2. It has benefits of $5.5 million compared to costs of $4.5 million. And you can see the itemized benefits that have been included for the project. And there really are a combination of benefits that are driving this project. I mean, you have health benefits, but you also have those additional safety benefits because of the interchange improvements. And in addition, you have those journey quality benefits due to upgrading the facilities to higher level facilities for both bikes and pedestrians. And like the other models, all the emissions are itemized below. The one part I didn't talk about was the non-infrastructure project. I'm just going to show it. You don't really need it for the SB1 program, but it does this calculation of a impact score So what are the dollars per score? And this is something we were developing for the active transportation program. And so what you would do is, for that media campaign, there's another set of tables in that tab 1B where you'd enter in information, and you'd also enter in information about the cost of the media campaign. And then it would calculate that kind of cost effectiveness ratio. So, it says lunch. Before lunch, we're actually going to take questions.
This is interesting, but I was wondering, obviously the input assumptions are critical here. And two questions I had here. One is, when we've done this in the past, we've done it a few times, we've always struggled with how do you determine how many new bicyclists you're going to get. And it just seems like it's just shot in the dark. And you mentioned the statewide travel survey, but I don't know if you have any other options. The other question, I just noticed that you have a reduction in accidents from bicycling. And so I just wondered if that's like national data that you find that bicycling is safer than driving. Is that for the person doing it?
So for the first question, this really gets at the demand question. You know, how many people are you going to attract to these active transportation modes? Just because you build it, are they really going to come? And how much demand is there currently for the facility? And yeah, that's right. It has to be net new. It can't be someone who took a different route and all of a sudden just kind of swapped over here and they appear, but they're not new. This is something that we didn't tackle as part of developing this tool, and we didn't for a couple of reasons. I mean, one, we were wearing our economist hats rather than planning hats and said, this is an economic tool. We're not going to get into the planning aspects of the project because this is part of what you need to do as part of your upfront planning. I mean, obviously, you don't want to design a facility if you don't think there's any demand for it. So, I mean, there should be some local knowledge about the demand for that facility. That being said, I know there are not a lot of tools out there, and it's a hard thing to estimate. There are a few MPOs that have built Excel models that have some elasticities built in and calculate some demand from that. I know of one MPO that actually has active transportation in their travel demand model so that they can try to figure out shifts in the future from active transportation. To be honest, I don't know how sensitive those models are to small facility changes. They may not really capture that. So there are a few tools out there. There have also been a few handbooks and guidebooks that have come out of some national research. But this is sort of a longer-term question of does Caltrans need to get into building a active transportation demand sketch tool? And, you know, this feedback is similar to some of the other feedback we've gotten that there does seem to be a need out there. But for right now, I mean, the assumption is that people that are using the tool would have either local knowledge or their own methods for estimating the demand. And I'm sorry, I forgot your second question.
The second question had to do with the data you have on safety for active transportation versus vehicle travel, for the passenger or the
right.
commuter.
Okay. So when the safety benefits are calculated in the model, there actually are two kinds of safety benefits. There's one that recognizes you have a different safety exposure by shifting from an automobile to cycling. And so we look at the change in the accident rate from the auto mode to cycling. And then on top of that, we added an additional safety benefit, which is if you're already using the facility, you already are a pedestrian or a cyclist. You have some kind of accident exposure rate currently, and you can get that from current statistics. Then when you add in those amenities, like the countdown signal, having stripe, actually having a crosswalk, that improves the safety. And so there is research that shows safety or collision reduction factors for particular kinds of improvements, whether they're for cycling or for pedestrians. And so there's different tick boxes that you enter in the beginning are affecting those safety calculations. And each of those reduction factors are documented in the technical documentation. So you can go and you can see all the technical research.
I guess we are the only two, huh? Quick question. Will we have an opportunity maybe in future, Rose, maybe this question is for you, whoever is conducting this seminar workshop, where we may actually have hands-on on an actual project, something that maybe to look into future rather than just general?
We're already planning some sort of training for districts.
Perfect.
So.
That will be great because, as the gentleman mentioned, the inputs are very critical. If your inputs are not good, it's garbage in, garbage out. And that's what we've been experiencing. I mean, we understand. But as you said that, for example, on my project of 205, which is a 13.4 mile long corridor of HOV lane on either side, it doesn't give us the results that we want to see. And you said that maybe we need to split the directionality and then add. I understand conceptually, but I don't know exactly how to do it and where to put what number. If we miss one cell, we are going to get garbage result.
Yeah.
So that's where we need real help.
Yeah. And so these, and I agree, I think hands-on is a good way to do that. I mean, the way these tools were set up is to really be an aid. It's a standardized approach because you don't need a CalBC model to calculate benefit costs. I mean, you can go open up an Excel spreadsheet and do all the calculations by hand. And it's actually not that hard to construct a benefit cost calculation. But these tools were set up to have a standardized approach so everything's looked at the same way, and it's simplifying it so you're not setting it up from scratch every single time. It doesn't take away, though, the expert judgment you have to make in terms of how do you capture the benefits of your project and having knowledge about what does your project do. And so, you have a spreadsheet here that's already been programmed for you, but you still have to kind of think through what your project is doing and how does it get those benefits. Do we have any questions on the computer as well?
I have a quick question about your users for the demand.
Yes.
Could you go back one slide? Oh, it was the section where, yes. So your user characteristics, and I can't see very well from here, but can you go back through your discussion where you said, like, I think your no build is the same as your build, and I think is because you were saying.
Was it this part right here?
No, it was
Okay.
It was that next slide where you said that you were getting the numbers from your travel survey.
Oh, okay.
Right,
So,
that breakdown of percentages
Yeah.
is from the travel survey, and from here, I think you said that your no build numbers are the same as your build.
the reason they're the same here is because we need to know, this is for trip purpose.
Yes.
To understand, why people are making these trips. And so you may know nothing about what the trip purposes are for your bikes and pedestrians. I mean, you may have no knowledge whatsoever. So to knowing that there isn't as much information about active transportation modes, we went into the statewide travel survey to collect that data. And so we got what the trip purposes are for the active transportation modes split out by bike versus pedestrian and by region. And so when you pick the 1, 2, or 3 here, the Southern California, Northern California rural, just like you would do in the regular CalBC model, it then goes to that data and self-populates what the trip purpose is. And the reason they're the same in the build and no build is it's just pulling from the same statewide data. If your project would change the trip purposes and the usage, I mean, you should be putting in the right trip purposes here. They happen to be the same here because we didn't change them for this example.
So if you're adding a new facility, like a class 3 facility or a class, I don't know, I don't think you're talking about a class 4 facility, but a separated facility, would you suddenly have more users in your build for your recreational purposes?
You might. And so
is this taking that into account, is my
Well,
question.
it takes it into account if you change the inputs here. So what this is doing right now, because these cells could have all been green and blank. I mean, we could have just asked everybody, just give us the trip purpose breakdown in the no build and the build. But we tried to do a little bit of the heavy lifting for you because we knew that data is not readily available. So we're automatically pulling in the statewide travel survey data. But ideally, you would put in different data. And the project you're saying, yeah, you probably would have more recreational users. And so you probably would change this trip purpose. But it's a function of going back to that travel demand question. How many people do you attract? And do you think all those people will be recreational people? Or will they be bike commuters? Or will they be kids walking to school? I mean, there could be a number of different purposes. And so when you enter in your data about the number of trips, you also have to think through what the different trip purposes are and put the percentages here. And part of the reason that it's important to put these trip percentages in is less important for SB1, but more important if you use this tool for other purposes. If you apply for a Tiger and Infra grant application to the feds, they don't recognize recreational trips as benefits. So one of the yes/no boxes is include recreational trips, and you can turn it on and off. So if you're doing a Tiger or an Infra grant application, you turn it off, and every one of these percentages here that are recreational trips, those benefits just get ignored, because that's what you need to do for a federal grant application. In California, we are including the recreational trips.
Just a couple of house cleaning responses. This webcast will be posted online. Give us a few days, and we'll post it to the EAB website. And then in addition, you can download the presentation now on our website as well. There should be a banner flashing in the webcast right now. It's a tiny URL, which you can just enter in that web address, and you should be able to download the presentation. Now for the specific general questions. Few common questions are, I think you touched on this as well, but just about how to go about ensuring that the inputs are reliable and how do you calculate it, which you've already touched on. One person did specifically ask, can you specifically name or recommend somebody that they can talk to, one of those agencies, to go about estimating the inputs?
So, one of the agencies we came across that does have a elasticity model is LA Metro. I haven't looked at their spreadsheet in great detail, so I don't know what it includes or if it would be applicable for their particular project, but that may be one place to go.
Okay. And then another common question is, what does a negative result mean? There's been a few people that have already been testing the model and they've been getting negative results.
Negative results sound bad.
Yeah.
Is that a risk? Because usually you have a BC that is either 0 or a positive number.
Well, you can have a negative BC ratio, but what that's telling you is you're making life worse for people. That, you have negative benefits overall. So that's not a good project. So probably it would be good if anybody is getting those results, why don't you email the Transportation Economics branch, and at the beginning of the presentation, we didn't actually say it, but the email address was there, and at the very end of the presentation, we have a slide that says how to contact us. I would encourage you to get in contact with people because we need to help you figure out what's going on with your project.
And then there's one specific question. How would the benefit cost tool work for a new pedestrian bike bridge over a freeway? What accident data would be used since there is no facility in the existing condition?
So I don't think for that project you'll have, if there is currently no way to cross the facility, and this new bike bridge is the only way to cross the freeway, then obviously there is no accident rate to compare to, and safety is not going to be one of your big benefits. What you'll probably have for that project are travel time benefits. And so for existing travelers that are somehow getting from one side of the freeway to the other, maybe they're taking an overpass and riding on the side of the road instead of taking the dedicated bike bridge, you can look at the changes in the travel time. So you have a before and an after. If you are getting people out of their cars, then you're going to see the changes in the travel time and the reductions in accident rates because you avoided all of those auto accidents. You would need to include some kind of accident rate for the new facility. And, we did not include a statewide average. I think the best thing to do there would be to look at some other local facilities, look at what accident rates are for the area, and then input that as your accident rate for that particular facility. Are there any other questions?
No, that was it.
Okay. Any other questions in the room?
I'll ask after lunch.
Okay. So we scheduled an hour and 15 minutes so people could go out and get lunch somewhere. We're going to start back up at 1:15. The webinar will start back up at 1:15. We're going to be on pause for the next hour and 15 minutes. After lunch, we're going to talk about Cal BC Corridor, the freight model, and the SB1 emissions tools.